Hi, I'm Mads Torgersen, and I'm a PM on the C# language design team. I'll give you a quick tour through the features we're adding to the next version of C#. In C# 6, as we call it, we haven't really added any sort of big new concepts that you have to wrap your head around. It's more a list of small, useful features that help clean up your code and get rid of the boilerplate that gets in the way of expressing your intent clearly. So let's go through this list and have a look. We'll start out with auto properties. Currently, auto properties need to have setters, and this kind of puts immutable data types at a disadvantage. That's a shame because there are all kinds of good reasons to use immutable data types, and we shouldn't get in the way of that. So we now allow getter-only auto properties. They have a backing field that's read-only, and just like read-only fields, they can be assigned from the constructor. That doesn't call a setter, it just assigns directly to that backing field. We also allow initializers on auto properties in the same way as we do for fields. Using clauses, we're letting those refer to static classes, not just to namespaces. And so what this does is to put the static members of the class directly into scope. So if you look at this static method call, for instance, you don't need to prefix it with the class name anymore. You can just call that square root method directly. That's great for when a static class is really just a collection of functions. You want to call them liberally throughout your code. String.format, very versatile, but this business with the placeholder numbers, it kind of gets confusing. It's error prone, and frankly, it muddles your intent. It would be much better if the values that you're formatting in, so to speak, if they occurred in their place. And that is what string interpolation is for. If you look here in interpolated string, you can define these holes with escaped curly braces, and you can insert the values directly where they're supposed to go in the string. So we do the call to the string.format method, and you just apply this enhanced string literal. There are lots of methods like this, where the body is just a single return statement. For lambda expressions, we already give you the option to just use a single expression rather than the whole statement body. So why not do the same for methods? We use the lambda arrow to let you implement a method with just a single expression. This goes for other kinds of function members too. For computed properties, it's often like this, a getter with a single return statement. That's even more boilerplate than in the method before, with 2 levels of curly braces required. But now you can just write it like this, a lambda arrow and an expression. So let's pause to appreciate how much simpler and clearer this class declaration has gotten. This is the kind of effect we're hoping for in your everyday code. But wait, there's more. Here's a method to turn our points into JSON objects. Today, you can initialize properties in an object initializer, but index setters still have to be assigned in separate statements. Well, not anymore. You can now assign to indices inside object initializers, so that J object can be initialized in just one expression. That leads to this cascading effect of simplification. We don't need the temporary variable anymore, and now we have just a single return statement. So in fact, we can just turn the body into an expression like you saw before. Things get so much clearer. Let's also look at the method to turn JSON back into point objects. The logic here to actually do that is just one line of code, but the bulk of the method is taken up by checking before you do it that you actually can do it. And most of that is about checking for null. So that's a nuisance. First we check that JSON itself is not null before we index into it. Then we check that the result of the indexing isn't null before we access its type. Twice. So null conditional operators are a feature to make this null checking kind of fade into the background. Let's first look at those innermost null checks to get to the type property. Now we've removed the explicit null checks and instead make use of this new question dot operator. It works like this: if the left-hand side is null, the whole thing is null. And only if the left-hand side is not null, then we do the dot, and that becomes the result of the operation. You'll often hear people refer to this question dot operator as the Elvis operator. If you look at it, you can see why. It's 2 eyes with this rockabilly swoop of hair on top. Now, we have just that initial null check to see if we can index in the first place, but indexing can be made null conditional too. You just insert a question mark in front of the square brackets, and now they only happen if the receiver is not null. So now, the whole if condition just expresses your core intent, which is, if there is a type, then it should be integer. A great use of these null conditional operators is for triggering events. Today, you trigger an event like this, but first you have to check if it's null. But this way of checking isn't thread safe because someone might unsubscribe the last event handler just after you checked, and boom. So you need to copy the delegate reference first before you check and before you trigger. But with the null propagating operator, this pain will be gone from your life forever. You just conditionally call the invoke method on the delegate, and it will get called only if the delegate isn't null. So, problem solved. Quite often you need to get the name of a program element as a string, like with point here. The problem with that is that if you rename point, you're likely to forget changing the string, which is now out of sync. So the name operator just lets you get that string while checking that the program element exists and what it binds to. So if you do a rename refactoring, for instance, the string changes too. There are a few improvements around catch and finally clauses too. Visual Basic, F#, they both allow a catch block to filter its exceptions before actually catching them. And now C# allows that too. This is better than catching and rethrowing because when you rethrow an exception, you lose the information about where it originally occurred. So downstream, you get a worse exception. Also looks better, right? Also, you can now have a wait in catch and finally blocks. This was missing primarily for implementation reasons. Frankly, we just couldn't wrap our heads around it, but now we figured it out. So this should be a really welcome change. It's a common scenario, and the workarounds you had to do without this were pretty hideous. So I hope you're as excited as I am to start writing cleaner, clearer code with C#. If you want to learn more, head over to our Codeplex site here. I publish the language design notes over there on a running basis, and there's lots of community discussion. Also, you can find links there to more resources. So, have fun with C#6, and thanks for watching.